Okay, so we did limiting reactant, and now we are going to look at percent composition and empirical formula. Okay, and percent composition is what the name suggests. It is the percentage of all the elements. Okay,
Yes, sir.
so if we are given that, we say that if we have gasoline, say, okay,
Okay.
and if we say that it has 84.1% carbon and 15.9% hydrogen by mass, then we can say that in 100 gram sample, we will have 84.1 gram carbon and 15.9 gram of hydrogen, right?
Yeah. Yes, sir.
Okay, this is the same thing, right? Now we are going to continue and we'll see how to calculate the percentage of composition. So this is fairly simple. So after that, what we will do is that we will calculate the moles. Okay, what we will do, we will calculate the moles.
Okay.
So if our colorless liquid whose sample we considered, right, it had 84.1% carbon and 15.9% hydrogen by mass, and what we did was that we immediately took 100 grams, right, because 100 grams will make it easier for us, right?
Yeah.
So we immediately took 100 grams, and then what has happened is, if you can see that I have 84.1 gram of carbon, and then also what I have is uh, so 84.1 gram carbon, I can calculate its moles, right?
Yes, sir.
Okay, 15.9 gram H. See, Ritika, these are elements, huh? H element. So what is the molar mass of H? 1.008. Huh?
Okay.
Okay. So you can take it one, huh? Okay.
Okay. Over here it's carbon and hydrogen, right? Or
See, right? We just got 84.1% carbon. It means the moles will be 84.1 gram divided by 12 gram per mole, right?
yeah. Yeah. Yes, sir.
See, this is the thing. This is what they have done. Huh? They're divided by the molar mass. Is just a fancy way of writing. Okay. So we
Okay.
can get the moles of carbon, right?
Yes, sir.
Similarly, I can get the mole of hydrogen, right?
Yes.
15.9 gram divided by its molar mass, 1.008 gram, right? Per
Yes.
mole. Okay. So now I have moles of carbon. Okay. Now I have mole of carbon and I also have 15.8 mole of hydrogen. After that, see what we do is we will say that its formula is C7H15.8. Okay.
Yeah.
But we know that this cannot be true, right? Because hydrogen cannot be 15.8, right? I cannot have 15.8 i's, right? Either I'll have integer, right?
Oh, yes, sir.
So what we do, Ritika, is we divide this thing by the smallest number. Smallest number of these two is 7, right?
Yeah. Okay.
So we have to see divided by both by 7, right?
Yeah.
To get the simplest ratio. And we got the simplest ratio as carbon 1 and hydrogen, how much? 2.26, right?
Okay. Yeah. Yes, sir.
Okay. But we know that they must be uh,
Yes, sir.
they must be whole numbers, right? Okay. So what we do is I take C1H 2.26 and I start multiplying them by integers. First I multiply them by 2. If I multiply both by 2, I will get C2 and H something like 4.52.
Yes, sir.
But this is again not then I multiply by 3, I will again not get. But when I multiply by 4, what happens is I get C4 and H 9.04. So it is almost an integer. So we'll write H4, C4, H9. Got it?
Okay, but why did we multiply over here?
We are multiplying because we are trying to find the simplest whole number ratio. Huh?
Okay.
So initially, what we did was we calculated the moles. Then what we did was we divide them by the simplest, smallest number, right?
Yes, sir.
And finally, when I have C1H 2.26, I know this cannot be true. So I must make them both integers. So I'll start multiplying both of them by 2, 3, 4. until I get full integers, huh? Okay.
Yes, sir.
Okay, this is how we find the empirical formula. And after we have got C4H9, we immediately see that these are integers. So this is the empirical formula. Got it? For that gasoline. Empirical formula is the simplest ratio of the atoms. Okay. Can you hear me? Do you have the power cut? Okay, let me know when you can hear me.
Yeah, sir. Power. So can you
Yeah. No problem. Okay, so empirical formula is nothing but the
simplest ratio?
simplest ratio. Got it?
Yeah. I just still do not get why we divided in the first case and we multiplied.
Because this is the method. Because we are trying to see, initially we got C7H15.8. So we have to fix the numbers, right?
Yeah.
So it is best that first we reduce them to the smallest numbers and then start multiplying, right?
Oh, okay. In this case, it's already the smallest number.
So when we have
Second case.
C7H15.8, what we do is first we will make it very simple. Okay. So we'll if we divide both by 7, I will get 7 by 7. So this becomes at least one number is becoming full integer. Huh?
Yeah. Yes,
Okay.
sir.
So after this, we start. After this dividing by the smallest number, then we start because it is easy to see what we have to do. Okay.
Okay.
We have to C1H2.26. It is much easier to see which numbers we have to multiply and get them. Okay, because
Yeah.
they can be smaller than 7 also, right? We don't
Yeah,
know,
yes, sir.
right?
But why did you multiply it by 4?
We started by trial and error. First we multiplied by 2. We did not get any full integer C. We got C2H4.52. Okay.
Oh, okay, okay.
Then
Oh,
we
you want
multiply
to,
by 3. I
okay.
still do not get a full integer.
Oh,
Okay.
okay. So you multiply until you get a full integer.
Yes. We
Okay, got
multiply until we get a full integer. Got it?
it. Yeah, makes sense. Yeah.
Okay. Okay. And after that, when we have got the full integer C4H9, then we know that it is the empirical formula. Okay. Now,
Yes.
what is the empirical formula mass? Empirical formula mass, if you see, 4 carbons are there. So 4 into 12 plus 9 hydrogens. 9 into 1 approximately. 1.008 they have done. So it will approximately it is 57 gram per mole. Okay.
Yes, sir.
Now, suppose if we are given that the molar mass is, if we are given, okay, if we are given that the molar mass is 114.2, okay, then first we find out how many simplest units are present in the actual compound. Huh?
Okay, yes, sir.
So if the molar mass is 114 and the mass of one unit is 57, then how many units are present? What we do is we divide molar mass by the empirical formula mass. And in this case, when we divide, we get 2. Okay.
Okay, and how did you get the empirical? Okay,
Okay,
empirical
empirical
formula.
formula mass because C4H9 we can calculate, right?
Okay, so in initially for molecular mass, right? For molar mass, you just did C1H2 or
Sorry.
like how did you get 114.2?
It's given. It's given.
Oh, okay. So they give the molar mass
Yes,
and you
they'll give
calculate.
the molar mass. You'll calculate the empirical formula mass and you divide, and then you get the number of units. Huh?
Okay, yeah.
Okay.
Fine.
So it means there are 2 units. So actually, C4H9 was my empirical formula, but I have 2 units. So if I multiply, I'll get C8H18, right?
Oh, okay. Where
So,
is
so
given
that
that?
is how we calculate the molecular formula. Now we know that it is octane and octane's molecular formula is C8H18. Yes,
Okay.
please ask. if you want to ask me.
No, sir. This is multiple.
This is?
This is for the multiple, the amount of times the thing is multiplied with, right?
I did not get you, sorry.
No, this formula is for the multiple, right?
Yes. Huh? Molar mass by empirical formula mass, right?
Yes, sir.
Got it?
Yeah.
Okay, great. Suppose now similarly, okay, if okay, next is if we have to calculate the percentage composition, okay, mass percent by mass, then it is very simple. Suppose if I know the formula C9H8O4, right? If I am asked to calculate the percentage of carbon, percentage of hydrogen, percentage of oxygen, then it is very simple, right? First, I calculate the
Yeah.
total mass. Okay, total mass of this will be 180. Okay, when you calculate. Okay,
Okay.
so what is the mass of carbon? It is 9 into 12, 108. So what is percentage of carbon? 108 divided by total mass, 180 into 100, right?
Okay.
It's percentage, just like the normal calculation we do for percentage, right?
Okay, yes.
Okay. So yeah, this is the thing. This is how we calculate the percentage of this. And it's very simple, so we don't have to worry. Now what I want you to do is, this is the vitamin C, okay?
Okay.
And first you calculate the empirical formula mass, and then I will give you the molar mass, and then from there you calculate the molecular formula, okay?
Okay, yes, sir. But
Yes,
whenever
please
you
ask.
don't give total mass, we'll take it as by 100, right? 100 grams is the
Yes,
total
yes.
mass.
We start by 100 because percentage is given, so everything becomes easy, yeah?
Okay, yeah. So over here it will be 40.92 grams,
Yes.
4.58.
So on. Don't worry and don't worry. Just start doing. Don't worry if you are doing incorrectly. Okay.
Yeah, yes, sir.
Yeah, right. The
Yes,
same
sir.
basketball. You
Yes,
never
sir.
learn without making wrong shots, or do we learn?
Yes, we do learn, sir.
Michael Jordan never could learn without making incorrect shots. Neither did Kobe. Okay.
Yes, sir.
But in India, people are learning without making mistakes. Huh? That is why we are not reaching anywhere. Okay.
Okay, sir. I'll make mistakes.
Okay. So come here. When you come to my class, what is your purpose here? We are here to make mistakes. Okay.
Okay. Okay. Yes, sir.
Right? Yeah. No, don't laugh. I'm very serious.
Yes.
Because mistakes are going to point me, mistakes are my friend. They are going to tell me what I need to do correctly. Right?
Yes, sir.
Okay.
Yeah.
And if we don't know our mistakes, our weak points, then how we will improve, right? Simple.
Sir, so I got the number of moles, right? After that, what should I do?
Open this on these notes on the alternate windows if you can, and so that you can go back and forth. See, you can see the method. What after moles, what we do? See, we write as C7H this and O, and then we divide by the smallest number, right? Everything, huh?
So I'll just tell you what I did was I did 40.92 divided by 12, then 4.58 divided by 1, and 54.50 divided by 60. And they're all like decimals. Nothing is a whole number.
It does not matter. Just divide by the smallest, okay? Okay?
Oh, okay. Oh, okay.
Okay?
Yeah,
Does not matter.
I'll do it.
Yep.
So for one, I'm getting C 3.41 moles, H 4.58, and O is 3.40. So when I divided 3.41 and 3.40, it's coming as 1.00294. It keeps going. So do I take that as just one?
You can take it as 1.
Okay. So C1H13O1.
C8.
No, C10.
Okay.
C10H13O10.
O10.
Yeah,
See,
I've
how
gone
did you
wrong.
start?
Okay.
What did you get? I mean, initially you got the moles, huh?
Yeah, for the moles, I got carbon as 3.41,
Hmm.
hydrogen as 4.58, and
Hmm.
oxygen as 3.440
3 point.
mole.
So which was the smallest?
Oxygen.
3 point by you divided everything by 3.40, huh?
Yeah.
Then okay, what did you get?
C1H1.3O1.
Okay. Uh, how did you calculate the moles? Run me through it.
40.92, like everything divided by the molar mass.
Yes, but you divided by for the first 40.92, right?
Yeah, I've taken all whole molar, like whole numbers, like 12, 1, 16.
So you get 3.41, okay, for the first. For the second, you'll get 4.58, right? Right?
Yes, sir.
And for the last one, for oxygen, you are getting 3.40, right?
Yeah.
Or you can also take it as 3.41 because it is 3.406, huh?
So I'll take it as 3.41.
Yeah, so the first and the last become same, huh?
Yeah, yes, sir. That's what I got.
And but hydrogen, it means we have 4.58, right?
Ha, yes, sir.
So if we divide 4.58 divided
Divided by
by 3.41, huh?
okay, I took it as 40, but I got it as 1.34, which I took
Yes,
it as
yes,
1.3.
1.34, huh?
Yeah.
Okay. Then we have to start multiplying them by integers, right?
Yeah, but sir, I later on took it as 1.3 because it will be easier.
No, no, it is not about your easy. It is about being correct, huh? You cannot take it. Okay.
Oh, okay, I didn't
For
know that.
them, you have to use two decimals, okay?
Oh, okay.
And
Then
you
I got
cannot
it.
round off, okay?
Okay. So
Yeah.
if I have to get rid of the decimal, I have to multiply it by 100.
See, you cannot say that, for example, you cannot say that, okay, I will use a ladder because it will be easy for me to score a basket. Huh?
Yes, sir.
Okay. You have to play by the rules. Huh?
Yes, sir.
Okay. So it is 1.34. Huh? Okay. Then you start multiplying them by successive numbers. Okay.
Okay,
So,
yes, sir.
so till here we have C1 H 1.34. Okay. And O1, right? Yes.
Sir, can you repeat?
Here again we have C1 H 1.34 and O1, right?
Yeah, that's what I got.
Okay. First of all, which internet you are using? Who is your internet service provider?
Airtel.
Okay. So there are two networks, right? One is normal and one is 5G, right?
Yeah.
So you are on 5G, check it.
Oh, I do not know, but usually like
Go to the Wi-Fi. Go to the Wi-Fi and check if it is 5G. I don't think so. It is 5G.
yeah, I don't think so either.
Yeah. We get two addresses, right? Whatever is the Wi-Fi name, and one is 5G and one is normal.
Oh yeah. Mine is normal one, which I'm
Yeah, yeah.
using.
Get into 5G. Yeah.
Ha, yes, sir. But like in my room, I have to get a booster or something because the walls are very thick, so it does not come.
No, no. It is showing 5G or not?
No, it's not showing 5G.
Not showing 5G.
But I
Oh,
have 5G though, like in my house, but it does not work in my room.
yeah, yeah. I got it. I got it. And what laptop is this?
Uh
Windows or Mac?
oh, Windows.
Okay. And how young it is?
Oh, it's not that young. Should be like 3 years, 4 years. Something.
Okay. Because sometimes they it might not show you the 5. When you go to other room today, check if it is showing 5G. Okay or not. Okay.
Yeah, yes, sir, but usually like in the previous class, I'm now sitting in my dad's room, so it works really well there.
No, no, works well is okay, but I want to check if it is 5G or not. It is showing 5G or not. Okay, later
Oh,
on do
oh,
that. Okay.
okay, sure, yeah.
Yeah. Okay. So we got C1, H 1.34 and O1, right?
Yes, sir.
Okay. And now we start multiplying. We first multiply it by 2 and we see if we get anything close to integer, which we
Yes, sir.
don't get.
But
Then we
yeah,
multiply by 3. Huh?
yeah,
After multiplying by 3, what we get?
4.02.
Yes. Everything is nice now integer. Huh? Close, right?
Oh, okay. So, I thought you have to get it as a whole number.
No, 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 no. You have to be but
Okay.
very close to an integer. Huh?
Okay, so
4.0 something. Okay. Whatever you will get, some number point 0 something. Huh?
yeah.
Okay.
So I
So
get like 4.0 something as 4.
yeah, yeah. Here, yeah, because that is the closest, right? Now we
Yeah.
are able to get C3H4O3, yeah?
Yes, sir. C3H4O3. Yeah.
Right? So this is
Yeah.
the empirical formula. Okay.
Oh, okay. Yeah.
What is the empirical formula, Mas?
Empirical formula was uh one sec.
Yeah.
104 grams.
Are you sure?
Yeah, 12 into
No,
6.
no. How much for carbons? 36, right?
Yeah,
4 for hydrogen is 40, right?
yes.
How much for oxygens? 3 oxygens?
Oh, I did 16 into 4. Okay, one sec. Yeah, 88.
Okay. Now suppose if the molar mass is 176, okay?
Okay, yeah, yes, sir.
Then I have given you the molar mass. Now you have to tell me.
Multiple.
Yes.
Uh, it's 2.
Okay.
So then I'll have to write it as C6H8O6.
Yes. Okay.
Okay. Yeah,
Got it? See.
yeah.
Now here is the solution. See. Go through it, read it, and when you're done, let me know. Till here you have to read.
Okay. Also, so while writing, do I have to write the 1 mole C divided by 12 gram C?
No, no, we will just do like this only, right?
Okay, okay, okay.
40.92 gram divided by 12 gram.
Okay.
Right?
Yeah. For that, yeah. Okay, fine. Okay, bye. Yeah, yes, sir. Done.
Great. And then I gave you the formula mass and then you're able to calculate, right?
Yeah, yes, sir.
Okay, great. Now 3.17. Okay.
Yes, sir.
3.18.
Okay. One second, sir.
No problem, no problem.
So what's it for magnesium?
24. But whatever the periodic table, did you check?
Oh, it hasn't come yet.
Okay.
So 0.98, I can take that as 1, right?
1 point?
No, 0.98. Can I take that as 1?
Yeah, you can take that as well. But yeah, you can take that as well. But initially, it is much better that if you don't, because you have to work through numbers initially, at least in this chapter. Huh? I understand.
Okay, so should I take it as 0.98?
What is it that you are getting as 0.98?
Oh, it's see, like when you multiply one carbons, 1 point, like molar mass
Okay,
divided.
after multiplying, yeah, then you can take.
Oh, yeah, because you need a whole number, right?
Yes, yes, yes.
Well, is it C2O6 Mg2?
How come 2 everywhere became simplest ratio? In simplest ratio, we can cut everything by 2, right?
Oh, again, yeah, then it will be C1O3 Mg1.
Right?
Yeah, is that correct?
Yes, yes, it is correct. And it is also MgCO3, right? Magnesium carbonate, right?
Yeah, MgCO3.
Got it?
Yes, sir. I'll just calculate the multiple.
Very good. Okay, then 3.18.
Okay, 1 second, sir. So what's the molar mass?
Molar mass for what?
Oh, okay. So I don't have to calculate multiple for this?
No, no, no. You don't have to calculate. They have just asked empirical formula for 3.17. No?
Okay, okay.
When they ask the molecular formula, then we need the multiple, right?
Oh, okay. Yeah, yeah, yes, sir.
Okay.
So what's nitrogen?
Nitrogen is 14.
Okay. So CnH4.
CN
H4.
CnH4. Okay. So CnH4 is, I think it is incorrect. Do it again.
So can you repeat what is wrong?
CnH4 is not correct. Send it to me. CnH4 you are saying, right?
Yeah. I'll tell you how. Can I?
Send me what you have done first.
I don't have my phone with me right now.
Oh,
Yeah. That's why I
okay.
couldn't send you homework also. Give me can I tell it to you?
Yeah, what? No, it's okay. But main thing is,
Yes, sir.
Hmm.
I'll just tell you the modes. See,
No,
for
no, it's okay. It's okay. Okay, run me through it. Just tell me how you've done.
for carbon, I got 3.33 more.
No, how you get? What did you
Oh,
divide?
40 by 12.
40 by 12 you did, okay?
Yeah,
Then you get 3.333. Okay. Then for hydrogen you get 13.3, right?
yeah. And then again for nitrogen, I'm getting 3.33.
Yes, 3.33. So you will get C. Okay.
So then I get C1H 3.99 and 1.
So till here we are getting C 3 point.
C1H 3.99.
No, H third initially.
Oh, okay. C1,
No, C 3.33, H
yeah,
13.33, and nitrogen
H,
3.33. Yeah, right.
yeah, yeah,
Then we divide this by 3.33, and when I divide 13.3 divided by 3.33, I get 4, right?
yeah, yeah,
So I'm getting C1H4N, right?
yeah.
Oh,
CnH4.
okay, what is its molar mass turning out to be? 16.
Uh,
Empirical formula. I think it is correct, Ritika.
okay, yes, sir.
It is correct. So we are getting yeah. And what is the molecular formula if the formula mass is this?
What is okay? So
See,
where?
we get the multiple.
Oh, they've given 60. Okay. So 2.
Yeah, go on, and tell me the full molecular formula.
C2N2H8.
Yeah, very good. Okay.
Yes, sir.
See, now we are going to see how to determine empirical formulas. Okay, this is called elemental analysis, and we are going to use combustion as a technique. Okay,
Yes, sir.
we'll do the same thing, but see what happens is in this technique, whatever sample we have, right? Whatever sample we have, we are going to first treat it with excess of oxygen. We are going to burn it. Okay, it is combustion analysis. Okay,
Okay.
so we just burn it in excess of oxygen, and we are going to get carbon dioxide and water vapor. Got it?
Yes, so just give me 1 minute.
Yes, yes, yes. Please, please.
Yeah, sorry, sir. Continue.
No problem. No problem. So after we have got CO2 and H2O, okay. Now, so they will give you how much of this is formed. So let us take this example in which we have burned 0.330 gram of naphthalene. Okay.
Yes, sir.
It reacts with O2 and we get 1.133 gram CO2 and 0.185 gram H2O, right?
Yes, sir.
Now we know that in order to calculate the empirical formula, I must know the moles of carbon and hydrogen, right?
Yes, sir.
So from whatever are the number of moles of CO2, that same number of moles will be of carbon, because in CO2 there is only one carbon, right? You got it?
Yeah.
Right? The same thing we said, right? Whatever we can say about the relative number for one molecule, we can say also about the relative number of moles, right? So
One second.
in one molecule of CO2, we have one carbon, right?
Okay. So, sir, can you, if you like, don't mind, can you like just say it again? Because
Yeah, yeah, yeah. See, whatever we can say about a single molecule. Remember, we did the counting thing and we said that first we just look at one molecule. In one molecule CO2, I have one carbon, right? So, are you here?
yes, sir.
So, yeah. So,
Yeah,
in one
yes, sir.
molecule in one molecule CO2, we have one carbon, and so in 1 mole CO2, we will have 1 mole carbon. 2 mole
Yeah.
CO2 will have 2 mole carbon. So whatever is the number of mole of CO2, that is the same number of mole of carbon. Okay.
Okay. Okay. Yeah.
Okay.
Oh, okay. So in this case, if you're saying like, let's have
Yeah,
1.3.
let's just calculate the number of moles of CO2, and that will be same as number of moles of
Oscar.
carbon. Okay.
Okay, but that's only in this case.
Yeah, in any case, if we take CO2, right? For example, if we take H2O, okay. If
Yeah,
I calculate the moles of H2O, what is happening in 1 mole H2O? In single H2O, in one H2O, I have two hydrogen, right?
yeah,
So if I have X mole H2O,
yes, sir.
then how many mole of hydrogen will be there? 2x, huh?
Yeah,
Okay.
but what happens to the O?
We are not considering O, huh? We are just considering carbon and hydrogen here, huh?
Okay, but I'm just saying, right? So when you take the entire number of moles for H2O, you'll
Yeah.
also take for O, right?
Yeah, for when we calculate the moles of H2O, we divide it by molar mass of H2O, right?
Yeah, yes, sir.
Okay, right,
Okay,
right,
yeah,
and we simply multiply by 2, right?
yeah,
Because in one H2O, there are two hydrogens, right?
Yes, sir.
Okay. So that is what they have done. That is what we will do. We'll calculate the moles of CO2, and the moles of CO2 will be same as the mole of C. So from there, from CO2 we are getting the moles of C. They will be equal. Okay.
Okay.
And from the mole of hydrogen, I am going to get from the mole of water, from the mole of H2O, I'm going to get the mole of H, right? So first I
Yeah.
calculate the mole of H2O, 0.85 gram divided by 18. Okay. And after that, what we do is we multiply that thing by 2, because the mole of hydrogen will be double the mole of water, right?
Yes, sir.
So after this, see, after this, when we are done with this, what we do is we calculate the mass of carbon. And how do we calculate the mass of carbon? Since we know the moles, we multiply by molar mass, 12 gram per mole, right? Yes. Let me know if you can hear me.
Sorry, sir. My internet is very bad.
Yeah, it's okay, it's okay. But do check for the internet, huh?
Yeah,
Right?
yes. It's just Mondays
Yeah, because I think it is
when
all
I
that
have at
5G
home, so
problem.
I
Okay,
cannot
you
see
have to
clearly
get that
slowly.
5G.
Otherwise, I'll.
Yes, without 5G,
Okay, yes, sir. Sure, I'll
yeah,
check it.
5G, without 5G, it will be a problem. Huh? So after, see, how we will
Sure.
calculate the mass of carbon? We know the moles, and I multiply by molar mass here, right?
Yeah, okay.
12 gram per mole. So why I am doing this? Just see. After that, I also calculate the mass of H, because I know the moles, I multiply by 1. Okay. Because the molar mass
Yeah.
of hydrogen is 1. So I get these two masses and I add them up. See, this is nearly equal to the sample's mass. Okay. Because the total mass of the carbon and hydrogen in the product is the same as the mass of the starting
Okay.
sample, 0.330 gram. We know that no other
Yes, sir.
elements are present in naphthalene, right?
Yes, sir.
Okay. And after that, we
Yeah.
just start with the same thing. Huh? See, I know the moles of carbon, which is 0.02 574. I know the mole of hydrogen, which is 0.025 0.0205. I divide it by the smallest number and I get this. Huh?
Yes, sir.
And then I start multiplying by it. Okay. Clear?
Yes, sir. Okay.
Okay. And finally, we get
I
this
think
integer.
as I do it.
Yeah. And this is the
Yeah.
empirical
Okay.
formula. Okay. And if you are
Okay, so
given the
it's just
molar
the
mass,
it's
then we,
almost the same.
sorry.
No, sir, continue.
So if we know the molar mass, in this case, it is given, it is 128.2. It is the empirical formula mass is 64. The molar mass is 128. So I can calculate the number of units, or the multiple. Multiple will be 2. So there are 2 units present in this, right? So C5H4 will become whole twice, right? For the molecular formula.
Yeah. Okay.
So this is same.
Yes, sir.
Here, only the thing is that we are not directly given the percentages. Instead, we are calculating the number of moles from CO2 and from H2O. Huh?
Okay, so we're directly getting the mass without the
Sorry?
percentage. That's all we're doing, right?
Sorry, what we are doing?
We're calculating the mass without the percentage. So
Yeah, yes, we are not given the percentages, so we have to calculate the moles other way around, right?
yeah, okay, got it.
Yeah. So that is what you have to do. Okay, very nice. Now, just see. Okay.
Sir, can you just show one question, like one
Yes,
example?
yes. This worked example. Open in the alternate window. Okay.
Yeah, from next class I'll open it because today already internet is very bad. So
Okay. Okay. See, first note the all this data, and then I will go to the next page.
the question, right, sir?
Yeah. You can write the data. Huh? That
Yeah.
0.5450 gram is the sample. Just write this, huh? In a notebook.
Yes, sir. Yes, sir, noted. Yes, sir.
So now we have the data. Now what we do is see. We have calculated the moles, right?
Yes.
Moles of CO2 is 1.023 by 44 gram per mole, right?
Okay. Yeah. Yeah.
And it will be same as the mole of carbon as discussed, right?
So this is the part I don't understand, right? So first you did 1.023 into.
Forget about it. See, how do we calculate the moles if we know the mass of? We simply do this, right? By 44 gram per mole, right?
Yeah, yeah.
So this is mole CO2, right?
Yes,
Yeah.
sir.
And this will be same as mole carbon, okay? As discussed. Huh?
Oh, okay, okay.
Okay.
Okay, yeah, fine.
Yeah. Same with the mole of hydrogen. First we calculate mole H, right? Sorry, mole H2O. Mole H2O will be 0.418 gram because that is it, the mass of it, and we divide it by 18 gram per mole, right?
Yeah, yeah,
And but mole of hydrogen will be twice of this, right?
yeah,
So whatever is this number, we'll get 0.418 by 18,
yeah.
right?
Yes, sir.
So after this, we see that, now we know the moles of carbon and hydrogen. Then we check why we are doing this step. What is the mass of carbon and mass of hydrogen? So that to check if there is any other element present or not. See, after how do we calculate mass of carbon? I know the mole of carbon. I multiply it by 12 gram per mole, molar mass.
Yeah, but sir,
Hmm.
my question was what happens to oxygen because there's O2 and O here, right?
That is coming from the external O2 which we are providing to it. First of all, got it?
Oh,
See what
okay,
we
so
do. What we do in this is that we are burning it. See, this sample, whatever we are burning, may have oxygen or may not have oxygen. Okay,
oh, okay, okay,
okay,
okay,
and we are providing this external oxygen.
okay.
Got it?
Yes, sir. But
Substance may have oxygen or may not have oxygen. That we do not know. For that, see what we are doing. So
so
I calculate the mass of carbon and mass of
yes, sir.
hydrogen, right?
Yeah, yeah.
And
Then you
after
subtract.
calculating mass of carbon and hydrogen, I add them and I see it is less than 0.450. So now I know that there must be some extra element present.
Yes, sir.
So I subtract this and I see how much it is, 0.124 grams. So that extra element is oxygen. Okay.
Okay, got
So
it.
in this case, oxygen is present. In the first example, oxygen was not
Okay.
present because
Okay.
carbon and hydrogen's mass added up to the mass of the sample, right?
Okay, yeah, yes, sir.
So here
So,
we have oxygen, right?
yeah,
And finally, we calculate the moles of oxygen. Because I know the mass, I simply divide by molar mass, 16.
yeah,
Huh?
got it.
So now I have moles of carbon, hydrogen, and oxygen. See, everything I have.
Yes, sir.
I divide by the smallest number, which is 0.00775. Okay.
Yes.
And here I get directly C3H6O. Okay.
Yes, sir. Got
So
it.
this is the
It's all
empirical
right.
formula.
Yeah,
Okay.
got it. Yes, sir.
And now empirical formula mass, if you calculate, it is 58. Now the molar mass is given 116. So it is twice. So it means the multiple is 2. Huh?
Yes, sir.
So I multiply everything by 2. I get C6H12O2. Okay.
Yes, sir. Got it.
Okay. Very good. So now try to do 3.20. Okay. You try to do 3.20 and then send it to me. Okay.
Sure, yes, sir.
So 3.20, if we can take 3, 4, 5 minutes, you do it. Okay. And then this is
Sir, I have a doctor's appointment, so I have to leave right now.
okay. No problem. You can send me both as well.
Yeah, I'll do it at home and I'll send it to you with the
No
previous.
problem. Okay. Chalo.
Yes, sir.
Okay.
Okay,
Take
sir.
care.
Thank you, sir. Thank you.
Okay.
Bye.
Bye.